Hi guys, this is Senthil, and what we are going to do today is that we are going to learn time, speed and distance. Okay, this is actually a very simple topic once you get the concepts right. Basically all topics are like that. Once you get the concepts clear, every topic gets simple. But the thing with time, speed and distance is that it revolves basically on just one formula. Okay, speed into time equal to distance. So everything revolves around in just this particular formula. So before we start the video, before we proceed to discussing the concepts and solving the problems, what I want you to do is that I want you to subscribe to the videos, subscribe to the YouTube channel, so that whenever I upload any new video, you're going to get instant updates of the video. Okay, so that would be this red color button below the video called as subscribe. Just click on that. That said, let's dive right in. So the thing is that mostly we'd be solving time, speed and distance using a traditional approach, but there is also this alternate approach to solving time, speed and distance, and that method, that approach is what I'm going to cover here in this particular video. So let's just look at the very first problem. Okay, moving 6-7 of its usual speed, a train is late by 10 minutes. Find the usual time to cover the journey. Okay, so this is the question, and what I want to ask you is that say suppose, okay, you are traveling in a car and you are traveling at a speed of 25 kilometer per hour. 25 kilometer per hour, this is the speed, and the distance that you need to travel is this is the distance is 100 kilometers. Okay, so how long is it going to take you to cover this particular distance? Okay, this is time equal to distance, so it's going to take you 4 hours, right? That is if you travel at 25 kilometer per hour, but you need to be at that place a lot earlier. So what you do is that when you start your journey, you hit your accelerator pedal as much as you can, and you travel at earlier you traveled at 25 kilometer per hour. Now you're traveling at 100 kilometer per hour. Okay, so how long will it take you to reach your destination? Okay, it's going to take you 1 hour. Okay, that is going to be 1 hour. So what happens here? Okay, if you see, what happens here is that my speed gets multiplied by 4. Okay, my speed gets multiplied by 4, and if you note the time, what happens to time? My time actually gets divided by 4. So 25 into 4 is equal to 100, right? And 4 divided by 4 is 1. So when speed gets multiplied by a certain number and when distance is constant, that time gets divided by that particular number. In order to prove that, what I'm going to do is that now I'm going to travel at 50 kilometer per hour. Okay, now I'm going to travel at 50 kilometer per hour. So how long will it take me? It's going to take me 2 hours, right, to cover 100 kilometer. Okay, now if I compare this, I'll take this as equation number 1 and this as equation number 3 and this as equation number 2. So if I compare equations 1 and 3, you see what happens. I'm multiplying my speed by 2 here. Okay, between 1 and 3, if I multiply my speed by 2, okay, it becomes 50 kilometer per hour. This is per hour. And just note what happens to time. My time gets divided by 2. Okay, from these things, or you can also consider equations 2 and 3. Okay, what happens between equations 2 and 3? My speed gets multiplied by 1 by 2. Okay, or can we say my speed gets divided by 2? Okay, if my speed gets divided by 2, my time gets multiplied by 2. Okay, you can put it that way too. So from all these, what we can conclude is that speed is indirectly proportional to time. Okay, when distance is a constant, speed is indirectly proportional to time. So what does that mean? If my speed increases, obviously my time is going to decrease. Okay, so you have to be there at some place, and if you travel at a higher speed, you're going to reach that place much quicker, right? So that is what I'm saying. If your speed increases, the time decreases. However, if you take too long to reach some place, obviously what it means, you're traveling at a lesser speed. If time increases, your speed decreases. Okay, this is a very basic concept that I'm going to use to solve most of the time, speed and distance problems. Okay, so I'm going to solve problem number 1 using just this technique. Okay, let's see what happens here. First, let me begin with my formula. Okay, speed into time equal to distance. Okay, I'm traveling at a certain speed and it takes me t time in order for me to reach the distance d. So that's the usual case scenario. But now my speed gets 6 by 7 of its usual speed. But now what happens to my speed? My speed becomes 6 by 7 speed. Okay, so we already know that when speed gets multiplied by some number, or time gets divided by the same number. Okay, this would be 6, this would be 7. If it gets divided, it will become 7 by 6. Okay, my time will become 7 by 6 in order to reach the same distance. Okay, now it is given that the difference between the times, okay, when I travel using my original speed and when I travel using 6 by 7th of the speed, reduced speed, okay, the time it takes, the difference between the times is given as 10 minutes. Okay, so what does that mean? That means this time and this time, the difference between these two times is 10 minutes. So what is that? 7 by 6t minus t is equal to 10 minutes. Okay, so what is my t? So my t is, this is 6 and this is 7 minus 6 t, which is equal to 10 minutes. So t is equal to 60 minutes. Isn't that what is asked in the question? Find the usual time to cover the journey. Okay, so that's what is asked. Suppose in case they ask find the new time, find the new time to cover the journey, then what will your answer be? We know that the new speed is 6 by 7 speed, so the new time is 7 by 6 of the original time. We know that this is the original time, so our new time is equal to 7 by 6 of the original time, which is equal to 60 minutes. So this is nothing but 70 minutes. So whatever they may ask, we can solve, you know. So this is the basic concept. We are going to see a number of problems based on this same concept, so it will come very handy. So it's actually, let's move on to question number 2. Okay, here it is. So what's given in question number 2? A boy takes 15 minutes less to run a certain distance by increasing his usual speed by 20%. What was the time taken to cover the distance at his usual speed? So again, if you look at this problem, you'll note that this is the same type of problem as the first one. Okay, in case you need some time to comprehend the question, you can just pause the video and look at the question. Okay, read the question and grasp what is asked. You may also try to solve this question before I solve, so that you can check with me whether you got the right answer, whether your approach was right. Okay, you can always do that. So to solve this, what I'm going to do is that I'm again going to start with my formula. What's my formula? Speed into time equal to distance. This is my formula, right? Speed into time equal to distance. Earlier it travels at speed s for a time t, and it covers a distance d. Okay, this is what happens normally. But now what he does is that he increases his speed by 20%. Okay, so in earlier case, if the speed was 100%, now the speed is 120%. What is 120%? It is 6 by 5, right? 120 by 100, which is 6 by 5. So now my speed actually becomes 6 by 5 speed. Okay, so we know that if the speed becomes 6 by 5, that is, if the speed gets multiplied by some number, or time gets divided by the same number. Okay, divided by, this is 6 by 5, this 5 will go to the top, so this is 5 by 60. Okay, and I cover the distance d. So they are saying that a boy takes 15 minutes less time. Okay, so compared to the earlier time, now the boy takes 15 minutes less. Okay, so what does that mean? That means the difference between earlier time and the present time is 15 minutes. So this is nothing but t minus 5 by 6t, which is equal to 15 minutes. Okay, so this is nothing but 1 by 60 equal to 15. This is 90 minutes. This is 90 minutes. Okay, apologies for the very bad handwriting. My gadget is going haywire at times, so have to bear with that. So this is going to be my time. So what are they asking here? What was the time taken to cover the distance at his usual speed? Okay, this is the usual speed, so t is our usual time. So what did we find out? We found out t, that is our usual time, so which is nothing but 90 minutes, which is 1.5 hours. Okay, so that is our answer. And now let's look at question number 3. Okay, so A is twice as fast as B, and B is thrice as fast as C. The distance, okay, this has to be distance. The distance covered by C in 56 minutes will be covered by A in how many minutes? Okay, so what have they given us? Have they given us the ratio the speed ratio or time ratio, or what is it? They have actually given us the speed ratio. It says that A is twice as fast as B. Okay, so what does that mean? So here is A, here is B. If B moves at 1 kilometer per hour, okay, A can move at 2 kilometer per hour. So A is twice as fast as B. And between B and C, B is thrice as fast as C. So if C's speed is 1, B's speed is 3. Okay, so B is thrice as fast as C. So all these things are my speed ratio. Okay, all these things are my speed ratio. So what's this ratio? What's the combined ratio between A is to B is to C? For that I need to multiply this by 3. Okay, what happens? This is 6 is to 3 is to 1, right? This is 6 is to 3. Both the terms need to be constant. Only then I can arrive at the combined ratio between A, B and C, and this guy remains the same. So this is my speed ratio here. Okay, so what have they given? The distance covered by C in 56 minutes. So they have said that C takes 56 minutes to cover some distance, and what time will be taken by A, okay, to cover the same distance. So they are asking for the time taken by A to complete the same distance. So what we need is the time ratio. So what we need to find out is the time ratio. Okay, so what's the time ratio? We know that speed is inversely proportional to time. So the time ratio between A, B and C is going to be 1 by 6, 1 by 3, 1 by 1. So this is the time ratio between A is to B is to C. If I'll make this, I'll just multiply the whole thing by 6 so that the ratio will look good. So this is actually 6. 1 is to 2 is to 6. This is the time ratio. This is the time taken by C to cover a particular distance, time taken by B to cover a particular distance, time taken by A to cover a particular distance. And they have already given that the time taken by C, that is the 6 parts, is equal to 56 minutes. And they are asking us to find the time taken by A. Okay, so time taken by A is what? 1 part. So if 6 parts is 56 minutes, 6 parts is 56 minutes. Okay, it's going haywire. What is 1 part? So 1 part is X. So it's just nothing but 56 by 6. Okay, which is 6 9s of 54, 2 by 6. We can further simplify it as 1 by 3. So time taken by A, right, be covered by A. Yes, time taken by A would be 9 1 by 3 minutes. So that is going to be our answer. Now let's go to question number 4. Okay, so a thief is noticed by a policeman from a distance of 200 meters. The former starts running and later chases him, both running at the rate of 10 km per hour and 11 km per hour. Okay, the distance between them after 6 minutes will be. So what do we have here? We have that okay, here is the police, here is the police guy, here is the thief, here is the thief, and the distance between them is 200 meter. Okay, as it continues to, I'll just change the pen. I'll just pick this one instead. Hope that this will be working well. Put this one up. Okay, so the distance between the police and the thief is 200 meter. The former starts running and later chases him, both running at okay, this guy runs at 10 km per hour and this guy runs at 11 km per hour. Okay, so the distance between them after 6 minutes. So again, what's the formula? Speed into time equal to distance. So the distance traveled after 6 minutes, so they have given the time. Okay, this is the time is 6 minutes. Okay, now what's the speed? If you know the speed, we can find what distance they have traveled. Okay, what distance they have traveled. The speed here is that of a relative speed. One guy runs at 10 km per hour, the other guy chases him at 11 km per hour. So the speed is a relative speed. So what's the relative speed between the police and the thief? It is faster speed minus slower speed, right? So faster speed is 11 km per hour minus slower speed, which is equal to 1 km per hour. So this is our speed. Our speed is 1 km per hour and the time taken for us is 6 minutes to cover a particular distance. So if we just solve this, we'll be getting the distance covered in that particular time. So if you note the units here, the unit is kilometer per hour, it is in hour, and here the unit is in minutes. So we have to convert this into meter per minute. How do we do that? 1 kilometer is what? 1000 meters. Okay, 1 hour is equal to what? 60 minutes. So this is in meter per minute now, right? And we already have what time, which is in minutes. So the distance covered would be 100 meter. So the if the police so what happens now is that the police has caught up with the thief. Okay, has near the thief. He has earlier the distance between them was 200 meter. Now the distance between them would be just 100 meter because he has already traveled 100 meter. Okay, so the distance between them would be what? 200 meter minus the distance traveled, which is 100 meter. So the distance between them would be 100 meters. So that is the answer for our fourth question. Now let's go to the fifth one. So what is this? So this is our fifth question. A car starts running with initial speeds of 40 km per hour, with its speed increasing every hour by 5 km per hour. How many hours will it take to cover a distance of 385 km? So what should we do now? Again the same thing, the same formula. Speed into time equal to distance. Okay, so what have they given? The distance traveled is 385 kilometer. So 385 kilometer distance has been covered, has been traveled. A starts running with initial speed of 40 km per hour, with its speed increasing every hour by 5 km per hour. So what happens? In the first hour it travels 40 kilometers. Okay, in the second hour it travels 45 kilometers, in the third 50 kilometers, and it goes on. So when we add all these things, all these distances, it should come to 385 kilometer. Okay, it should come to 385 kilometer. So if you note, this is this is nothing but arithmetic progression. Okay, the difference between them is 5, the difference between them is 5, the difference between this and the next one is also going to be 5. So it's a progression, it is progressing arithmetically. So what's the formula to find the summation of arithmetic series, summation of AP? If I remember the formula correctly, it is n by 2 into 2a into n minus 1 something. I'll just check the formula and I'll just resume the recording. Okay. Okay, let's resume from where we left. Okay, so this is actually the formula for the summation of AP, and what needs to be done here is that when you sum all these things, you're going to get 385 kilometers. Okay, but the thing is, how many terms are there, how many hours are there? Okay, this you travel in the first hour, this you travel in the second hour, this you travel in the third hour, and so on. So how many hours is it going to take us, okay, to cover this particular distance? So that's the key thing. So in order to find that out, we are going to use the AP summation formula. Okay, where the first term is 40, a is 40, and the difference between them, d is 5, and n is actually going to be or t here, because as you see, this is the first hour, this is the second hour, this is the third hour. How many hours do we need? Okay, so that is actually n. So n is what we need to find out, and the summation of all these things is 385. So what is this? This 385 equal to n by 2 to 2 into a is 40, 2 into a into plus n minus 1 into d, n minus 1 into d. So this is 380, 760, 770, which is equal to 80n plus 5n n square, 5n square minus 5n. We can cancel 5 from all these terms. Okay, so this is so this is 16 n minus n, which is equal to 15n. So this is n square plus 15n, right? And if I were to bring this 154 on the other side, this is minus 154, which is equal to 0. So this is our equation, and in order to find the factors, if we multiply, we should get 154, and if we add those factors, it should be 15. So that would be 22 into 7, right? And this guy is going to be a negative 1. Okay, so this is n square minus 7n plus 22n minus 154, and I'm going to solve the rest here. So if I'm going to take n now, this is n minus 7, this is n minus 7, this is 22. So n equal to minus 22 and n is equal to 7. We could just say that from here itself, but some of you might get confused, so I was solving these additional steps. So n is 7, the time cannot be a negative quantity, so this is ruled out. So the number of hours that it's going to take us to cover 385 kilometers is 7 hours. Okay, the answer given here is wrong, it should be 7 hours. This is your answer. Okay, now let's quickly go to question number 6. Okay, this is question number 6, and what is asked here: Sumit drove at the speed of 45 km/h from home to office, returning over the same route. He got stuck in traffic and took an hour longer. Also, he could drive only at 40 km/h. So what have they given here? It's the same as questions 1 and 2. Okay, it's the same. So what's my formula? Speed into time equal to distance, and they have already given me my speed. This is 45 km/h into some time. I travel for some time, and I am able to drive this particular distance. Okay, and while returning, okay, this 45 became 40. Okay, this 45 became 40 because he got stuck in the traffic, so his speed obviously got reduced. So how will 45 become 40? By what number? If I multiply 45, it will become 40. If I multiply it by 40 by 45, what happens? It becomes 45, right? It becomes 40, right? Okay, so what is 40 by 45? This is 8 by 9. Okay, so what happens here is that earlier my speed was s into t equal to d, and now my speed is getting multiplied by 8 by 9 speed. Okay, listen carefully. Okay, if you don't get this concept, just pause the video, reverse a few seconds, and again watch the thing. So my speed becomes 8 by 9 speed. So we know that if we multiply speed by a number, time gets divided by that number. So my time will become 9 by 8t. Okay, and they have already given that the difference in these times. In the second case, he is taking 1 hour longer, right? Because he got stuck in traffic and took an hour longer. So the difference between these two times, they have given it to be 1 hour. Okay, so from this we can find t. 9 by 8 t minus t is 1, so this is 1 by 8 t equal to 1, so t is actually 8 hours. Okay, so now we have found out to what our usual time is. Now from these we can very easily calculate the distance that he has traveled, because they have already given us our original speed. Our original speed is 45 km/h, and it travels for 8 hours. So what is that? 360 km. Okay, we can also verify our answer, or we can verify our concept by checking the second equation. When speed becomes 8 by 9 of the speed. Okay, so speed is actually 40 km, right? In the second case, this I'm talking about the second case, speed becomes 40 kilometers, and the time becomes a 9 by 8 of the t, 9 by 8 t. So our t is actually 9 by 8, sorry, our t is actually 8 hours. So what is 9 by 8 t? That is actually 9 hours, right? So our new time, okay, our new time, that is 9 by 8 t is 9, and so it is 360 km. See, if on both the cases we are getting the same distance, that proves that we are on the right path. So that is question number 6. Now let's go to question number 7. Okay, this is a train problem. A train leaves Manipur at 6 a.m. reaches Dispur at 10 a.m. Another train leaves Dispur at 8 a.m. and reaches Manipur at 11 a.m. Or what time do the trains cross each other? Okay, so this is train X and this is train Y. Okay, this guy is in Manipur at 6 a.m. It starts at 6 a.m. and this guy starts at 8 a.m. and is in Dispur. Okay, so it actually takes him 6 a.m. and he reaches at 10 a.m. It takes him 4 hours. It takes him 4 hours for this guy to reach, and it takes this guy 3 hours. 8 to 11, so it takes this guy 3 hours. So we do not know our distance, the distance between Manipur and Dispur, so we can actually assume a distance here. Okay, what I'm going to do is that I'm going to assume the distance, which is nothing but the LCM of 4 hours and 3 hours. Okay, we can actually assume our distance to be any distance, but if we assume the distance as the LCM of 4 and 3, it's going to be somewhat easier for us. So I'm going to consider the distance between Manipur and Dispur to be 12 kilometer. Okay, so since this guy starts at 8 a.m. and this guy has already started at 6 a.m., from 6 to 8 a.m. this guy would be traveling all alone. Okay, so this guy would be traveling. So how far you would have traveled? We know that so what's the speed of this guy is going to be? We know that the distance is 12 kilometer and it takes 4 hours to travel. So speed into time equal to distance. So if we need to find out speed, then that is distance by time, right? So distance is 12 kilometer, which we have assumed. From that we are going to get a speed, and the time it takes is 4 hours. So speed is going to be 3 kilometer per hour. Okay, so the speed of this guy is 3 kilometer per hour. Okay, so till 8 a.m. this guy is going to be traveling. So 6 to 8 a.m. is 2 hours, so this guy is going to be traveling for 2 hours, which is equal to 6 kilometers. So it would be right in the middle at 8 a.m. At 8 a.m. this X, okay, train X is going to be halfway down the mark. So what's the remaining distance left to be covered? Okay, in order for the two trains to cross each other, they have to cover, for example, if this train X is at this particular place, this train Y should be at this particular place, right? Or say if this guy is at this particular place, this guy has to be this particular place. So if you see whatever it is, this guy would have covered this much distance and this guy would have covered this much distance, so they would have covered the entire 6 kilometer, right? Between them they would have covered the entire 6 kilometers. So at what time will these two trains cross each other? So speed into time equal to distance again. The distance that they need to travel is 6 kilometer, and in this case we need to find out time t. So we are going to divide it by speed. The speed is going to go here. Okay, is going to go here. So that would be 6 by speed. What is speed? The speed would be that of a relative speed. So this guy's speed is 3 km per hour. So this guy travels 12 km in just 3 hours, so this guy's speed is going to be 4 km per hour. So both of them are traveling in opposite directions, so their speed is going to be a summation of this guy's speed and this guy's speed. So this is going to be 6 by 7. Okay, so at 8 a.m. they would be in the middle, and if we add 6 by 7 hours, okay, this is 6 by 7 hours, right? If we add 6 by 7 hours to 8 o'clock, we are going to get our exact time. Okay, so what is 6 by 7 hours? 60 minutes by 7 8s of 56, right? And 40. So this is going to be 6 by 7 hours. So that would come to what? That would be none of the options. That would be option D. Okay, so that would be our answer. Let's go to question number 8. So Sonu and Monu travel from point P to Q, a distance of 42 kilometers. At 6 km per hour and 8 km per hour. So here is Sonu, here is Monu. This is 42 km. So he travels at 6 km per hour, he travels at 8 km per hour from point P to Q. So actually that would be incorrect. So Sonu and Monu both are going to start at the same point, and Monu both are starting at the same point. Sonu travels at 6 km per hour and Monu travels at 8 km per hour. Okay, so this is going to be the distance that they need to travel. Monu reaches Q first because Monu is traveling at 8 kilometers per hour, so obviously he is going to reach Q first, and then what he does, he returns immediately and meets Sonu at R. So what happens is that Sonu keeps on traveling, but since Monu is the quicker guy, he just goes zoom here and then he returns back, and they meet at some distance. So Sonu is right here and Monu comes back and he meets him right here. Okay, so he meets him right here. So find the distance between distance from point P to R. Okay, from point, so this is going to be R, so this is P, right? So what's the distance, this distance P to R, what's this distance? That's what we need to find out. So we know that the entire distance is 42 kilometer. Okay, entire distance is 42 kilometer, and I'm going to assume the distance between R and Q as x kilometer. Okay, so if you see it's actually a very simple problem. If you just use a simple logic that the time taken by Sonu and Monu to travel whatever distance they have traveled is the same. The time taken by Sonu is the same, the time taken by Monu is the same. Okay, so where's our equation? Speed into time equal to distance. Okay, so how much distance has Sonu traveled? Sonu has traveled, so if we take this entire thing as 42 and this as x, Sonu has traveled 42 minus x, right? So let me consider the time taken by Sonu, which is equal to 42 minus x. Actually, let me just keep it as t, because the time taken by Sonu is equal to the time taken by Monu. Okay, so this is the distance that Sonu is going to travel, and it's going, and he has and his speed is 6 km per hour. Okay, and what's the time taken by Monu? How much distance has he covered? So see, this Monu guy is traveling at 8 km per hour. Okay, 8 km per hour. And what does he do? He travels the entire 42 km and he comes back. Let me change the ink color. Okay, what does our Monu do? He travels, okay, and let me change again another color, and he comes back here. So what he does, it has traveled 42 kilometers, right? Here he has traveled 42 kilometers, and he has traveled a further x kilometer. So he has traveled 42 plus x kilometers. So he has traveled 42 plus x kilometer, and his speed is 8 kilometers per hour. So this time taken by Monu, this is time taken by Sonu, but the time taken by Monu is equal to the time taken by Sonu. So what we can do is that we can put an equal sign between these two and start solving this. This is 168 minus 4x, which is equal to 126 plus 3x. So that is 7x. 7x is equal to 168, 126, 294, right? 294. So x is equal to 4 so 28, 42. So this x, okay, what are we doing wrong here? This is 168 minus 4x, this is 7x, and this is 126. Okay, we have to subtract that. Okay, sorry about that, we have to subtract that. Okay, that is 42. Okay, if we subtract, we get 7x equal to 42 kilometer. Okay, so we'd be getting x equal to 6. So this distance is actually 6. So what's this distance between P and R? It's going to be 36. Okay, 36 kilometer. So that's what they are asking. They are asking for the distance between P and R, which is nothing but 36 kilometer. So this is going to be our answer. So I'm going to end this particular video with this. In my next video I'll be covering more questions on time, speed and distance. And as I said at the start of the video, what I like you to do is that please subscribe to this channel, and I'd really like to hear your comments, whatever comments you have about the video. Okay, only then I can move forward, produce better videos for you, whether you are able to understand from the video or whether you get stuck at some points, or that you find some problem with my presentation or the pace in which I move. Whatever it is, you just feel free to comment, whatever it is, positive, negative, neutral, whatever it is. So I'd actually appreciate you doing that. So with that, let me end this video, guys. Thanks for watching.